Hello students, welcome back. We completed section 2, product and quotient rules. The next topic, let's consider some trigonometric functions. Remember, the elementary differentiation rules include the power function, natural exponential function, and natural logarithmic function. Trig functions are different. Oh, before starting that, remember these rules. The limit as theta goes to 0, sine of theta over theta is 1, and limit as theta goes to 0, cosine of theta minus 1 over theta is 0. The latter is a little less important, but this one is really important. Remember that. The proof, let's not worry about it here. We already covered it way back in lesson 2 as an optional topic because it was too advanced. So you don't have to know the proof, but the result everybody must know. Okay, alright. The derivative of sine is cosine, and the derivative of cosine is negative sine. And why is that the case? You can actually prove using Newton quotient computation and those limit computations, but this is not for everybody. So I'll just leave you there. If you're interested, go ahead with the proof. Otherwise, remember these as formulae. And then some other trig formulas here. Derivative of tangent is secant squared. The derivative of secant is secant times tangent. Derivative of cotangent is negative cosecant squared. Derivative of cosecant is negative cosecant cotangent. Let's see. Sine becomes cosine. Cosine becomes negative sine. So cosine becomes negative sine. Tangent becomes secant squared. Cotangent becomes negative cosecant squared. So secant, 1 over sine, 1 over cosine, cosecant, 1 over sine. And then derivative of secant is secant tangent. Derivative of cosecant is negative cosecant cotangent. Well, a lot of negatives are flying around. So these two, I'll try to avoid those two in exams. But in homeworks, I'll just use all those. This one, this negative, you have to bear it. Cosine is an important function. Now, as for inverse trigonometric functions, let's postpone those. Or maybe I'll cover those in an optional video here. But real inverse trigonometric function will show up several weeks later. For now, let's stick to these. Alright. First example here, let's do with some limit computation problem. Okay, in that case, let's open this one up. Limit sine of 7x, sine of 5x over x to the second power. We have a fraction, so I'd like to see it in a little bit larger font. Okay, which trig rule that you want to use in this case? Number 1, sine. Number 2, cosine. Come on, that's too obvious. Both functions here are sine functions, so clearly you'll have to use the sine rule here. 7x over 7x, 5x over 5x would have been great. That's not what we have over here. That's what we have. So let me manipulate it a little bit. Put 7 here, and then multiply by 7. Put 5 here, and multiply by 5, so that the 7x replaces theta. This 5x here and there replaces theta. So the answer is 7 times 5, that's 35. You see, sine of 7x over 7x, that's 1. Sine of 5x over 5x, that is 1. What's left is 7 times 5. Remember, using this angle here and that angle down there must be the same. If you have 7x, we need 7x. If you have 5x, we need 5x. We don't, so artificially make those. How about the next example? Well, it looks like we have a 0 times infinity type limit, but it doesn't have to be that bad. I can always change that into 0 over 0 type limit. Cotangent is, what is cotangent? Remember that? It's 1 over tangent. But tangent is sine over cosine, so cotangent will be cosine over sine. Alright, we're almost there. Which trig rule are we going to use? Number 1 or number 2? We have both sine and cosine, so which is it? I hope everybody can see. Again, number 1. We have sine x and x. So this one is x times over sine of x, and this one, change cosine of x like this. And this one, that's going to 1. And cosine of 0, that too is going to 1. Remember, cosine of 0 is 1. Sine of 0 is 0, but cosine of 0 is 1. So this is no problem. X over sine of x, that's 1, as you can see here, as long as we have the same angle. Previously, we didn't have the same angle, so artificially I had to create 7x and 5x. This time, no need for that. Here's a nice problem. This time, stop the playback and do it on your own. Clearly, you'll have to use the first rule. There's no cosine here, so it's got to be this one again. And the inside, the angle must be the same. I need x minus 1. And x is going to 1, so x minus 1 is going down to 0. Okay, all right. We need x minus 1. How do I get x minus 1 from here? Got it? Not yet? Factor the denominator. X plus 3, no problem there. Plug in x equals 1, that's going to 4, no problem. X minus 1 is going to 0, x minus 1 going to 0, same theta. So this one over that one is going to 1. So what is this? 1 times 1 over 1 plus 3, 1/4. So sine of theta over theta is 1. Okay, finally this problem. What do you think? So x is going to pi over 4. 1 over tangent over sine minus cosine. Oh boy. This time, sine of x and cosine of x will become the same. How do we work it out? Suggestion? Well, tangent is sine of a cosine, so maybe you can start from there. Does it help? Multiply both by cosine. Multiply each by cosine and cosine, and then this denominator will be gone. And then I have to multiply by cosine. What do you think? Did I do this right? I have denominator inside numerator, too complicated. Multiply by cosine to each of them. Cosine here minus sine, and then multiply by cosine like this. Any simplification? Oh, excuse me, cosine of x minus sine of x. Any simplification here? Well, cosine of x minus sine of x, sine of x minus cosine of x, do they cancel out? Yeah, they do. So we have -1 over cosine of x, and then x is going to pi over 4, so cosine of pi over 4 is 1 over square root of 2. Oh, excuse me. Alright, so negative square root of 2. Is that right? Yeah, negative square root of 2 is correct. Okay, that was a bit tough, but otherwise almost straightforward application of the first trig rule. This one here. Alright, we did some limit problems. How about some derivative problems? Let's do that in the next video.